we're graphing systems of equations. Whenever you see the word system, it's talking about more than one. You see it two? You can even have three sometimes, but for now it's two. So it's a system of equations, a grouping of equations. Now, these two are lines. These are all sets of lines. Now, if you have two straight lines, the solution is, so you have that line, and let's say you have that line. The solution is right there. Your solution is where they meet. The solution to a system of equations, the solution is right there where they meet. Now, the problem is, do all lines cross? No. Sometimes you might have this scenario. That's called parallel. Okay. And sometimes you have this kind of weird situation where you have one and then the other one right on top of it, basically. I didn't draw it right on top so you can kind of see it. Sometimes you get a graph right on top of it. Basically the same graph. So, this has how many solutions? One. One solution. How many solutions does this green one have? This has 0 solutions. And how many solutions does this have when it's right on top? It has infinite or a lot. So basically, if your lines cross, most of the time it's this one solution. Sometimes there'll be no solutions because they're parallel. Sometimes there's infinite because they're right on top of each other. Okay. So basically all we're going to do for number 1 here is graph both of these and find the coordinate where they hit. So if I want to graph the top one, do you understand that's like a -1 right there? Do I begin at the -1 or the 3? You should realize you begin at the 3. The -1 tells you where you're going to move, which in this situation is down 1 over 1. Now when you're graphing two graphs and you're trying to find out where they cross, it's pretty important to be accurate. So can I keep that pattern going? Could I also take the pattern backwards this way? Instead of going down 1 over 1, I could go this way and up 1. Anyways, it's just important to keep the pattern nice and clean. Now for this one, I'm going to do in green. Where do you begin this one? This one begins at -2. And the movement is 3 over 2. Up 3 over 2. I don't need another dot because basically that hits where I want to hit. I hit the other graph there. So, I graphed both my equations. How many solutions does this have? 1. And it's right there. What is the coordinate of that point where they cross? That's what we're looking for. That coordinate is over 2 up 1. So over 2 up 1. Could I check that solution? Yeah. Could I plug 2 in for x, 1 in for y? 1 goes in for y, 2 goes in for x. Is it a true statement? Yeah. If I plug 2 for x, 1 for y, it's true. If I do the same thing here, it also comes out true. This is the one coordinate that is true for both. Right. This was an easy one. They were both in proper form to graph. These two, we first had to change the form. So, for the first one, our first step to get y by itself would be to divide everything by 2. And you get y equals 5 divided by 2 does not reduce, so it's just 5 over 2 x, and 6 divided by 2 is 3. This one, when you graph it, begins where? Begins at 3. Now, can you go up 5 over 2 from this dot? On my graph, can I? No. If I go up 5 over 2, isn't that up here somewhere? So I'm kind of getting out of this graph. Now, could I go the opposite direction? If up 5 over 2 gets me over here, wouldn't down 5 and over 2, does that give me the same graph? Instead of going up 5 over 2, I could actually go down 5 and over 2. Just go the opposite direction for both. You sometimes have to do that, especially on multiple choice tests, if the graph doesn't fit the points you want. There's that graph. And the second graph, negative 10x plus 4y equals 8. I want to get y by itself, right? So I'm going to add the 10x over. I now have 4y equals 10x plus 8. And we divide by what? Divide by 4, divide by 4, divide by 4. And we now have y equals 10 divided by 4 is 5 over 2. 8 divided by 4 is 2. Now, what do you notice about this? Do they have the same slope?
Yep.
Which you hopefully know same slope means parallel. You'll see that in a second here. The 2 means we begin at 2. And again, we can't go up 5 over 2, so I'm going to go down 5 and over 2. And what you're finding out is these graphs are right parallel next to each other. Now, they're almost identical. They're almost right on top of each other, but in this situation, they're parallel. So my answer is no solution. Now, if you didn't, could you tell right away if they have the same slopes, there's going to be no solution? As long as you realize the b's are different. If the b's were the same, wouldn't it be the same line? This right here? If these equations were exactly the same, do you understand it's this one? Infinite? But if you have the same slopes, it's going to be this one, parallel.